And welcome back to week 4, 301X office hours. We are going to continue talking about the discrete time Fourier transform. This problem is going to be about plotting the phase and magnitude of a transform. So let's get to it. We have our function, cosine omega, e to the j omega, right? And notice that this is going to be complex valued. And we want to plot the phase and the magnitude. So we can recall that for complex variables, the magnitude is the number, the coefficient, the real coefficient outside the imaginary exponent, and the angle is the coefficient in the imaginary exponent. All right, so this is the phase, and this is the magnitude. Now, unfortunately, we don't have our function in this form, right? So, for example, cosine omega is sometimes negative, and that's not what a magnitude is. And so we need to manipulate this particular formula until it's in the form that we can then plot as separate magnitude and phase. So we're going to do a little bit of manipulation. Now, cosine, depending on what omega is, cosine is going to be positive or negative. So let's fix that first. Pi over 2, and when omega is greater than pi over 2, right? Because from negative pi over 2 to pi over 2, cosine is going to be positive, and then outside of that, it is going to be negative. All right. So we have taken our cosine and we've made sure that we have the right signs going on in our h with this particular manipulation. All right, so let's keep going here. We can notice that this negative is simply e to the minus j pi, so we can express this negative sign in an angle, okay, and we still have the same bounds on omega, when omega, how omega affects what h is, okay. And so noticing that this negative sign is an angle, we can then put it into our angle part, which is the imaginary exponent part, w minus pi. Okay, so this is for greater than pi over 2. All right, so this is great because now notice here that the magnitude is the same and that it is always positive, that it is a magnitude, right? And we've arranged our angle as well. So we can say now that the magnitude part, I'll write it over here, that the magnitude part of our dTFT is simply cosine of omega, right? And then the angle is going to sometimes, right, be w, right? And sometimes it's going to be w minus pi. All right, so now we can plot these. The absolute value of cosine omega looks something, woo, certainly doesn't look like, the axis certainly doesn't look like that, huh? All right, there we go. It's just going to look like the cosine, right? Until you get to pi over 2, which is when normal cosine goes negative, but in this case we have the absolute value, so it goes positive again, right? So this is omega, and this is the magnitude h, jw. Okay, and then as for the phase, we can do a similar thing, where this is omega, this is pi over 2, and this is pi over 2. All right, and it's just equal to omega when we're in pi over 2, so that's good. And then as soon as you go outside pi over 2, we subtract by pi. Okay, so then go down, come back up. In this case, like this. All right, and then this is the phase. All right, so the key thing to take away is that the magnitude and the phase are very important when you're looking at the DTFT, and that to get them, you need to manipulate whatever it is you end up with into a form that you can plot as, you know, a real coefficient times the real coefficient, which is your magnitude, times the angle, which is the exponent component, the coefficient of the exponent. All right, thanks.